So for different parameter values, so this is a production function again. So I kind of skipped that. I don't have any credit markets at the moment, so I just completely shut down all credit markets. So this is why there's wealth. Utility function, this is like a standard utility function for people who know that stuff. This is the fraction of low ability types is 60% of the population are low ability. So you're gonna get these wealth distributions where they're actually kind of like skewed to the left or to the right. I don't know, one of the two. And look, they look like this because they're more low ability types. So what I put on here is the probability of death. So 1 over the probability of death, remember, is like the expected lifetime. So here I took like extreme values. So one is 100 years expected lifetime, and one is 20 years expected lifetime, just because. So I think I actually switched those. So this should be 0.01 and this should be 0.05. So what you get is these wealth distributions. So the target wealth levels are here, and the guys are going to try to move towards them, but then they're hit by a shock, and so they're going to be somewhere here in the middle. And this is exactly what's going to generate misallocation in this model, is that not everyone is at their target wealth levels. So yeah, anyway, so we want to see, so you get these nice looking, well, fairly nice looking wealth distribution, and if you look, I don't know, I think this looks pretty nice. If you look at like data, what the wealth distribution looks like, kind of looks similar to this, sort of at least. And so now we want to look at what kind of misallocation you get out. So just as before, we're gonna put in a credit market where you can save up to some, where you can rent up to some multiple of wealth. Now we want to see what happens. So what you actually get, unfortunately, is only very moderate TFP effects with a realistic calibration. By realistic calibration, I mean, in particular, a realistic expected lifetime. But I'll come to that in a second. The reason is that, as I showed before, people kind of save up very quickly if their savings constrained. So as I had these graphs before, where like you had this gap of marginal products, right, and it narrows within like 5 years or something. Now the guys that would live for 50 years, or let's say for maybe you should put in 30 years in terms of like life expectancy that like managing a company is concerned, but they're gonna live for very long, and so they're actually gonna get out. So you get only here you get a 10% decrease in TFP if you have lambda. So lambda is on this axis, TFP is on this axis. TFP relative to like the first best. So lambda is how bad the credit markets are, or how good the credit markets are. So lambda equals 1 is completely shut down credit markets. Lambda equals 5 is like credit markets like in the US. And you get still pretty low TFP effects. So I'm not gonna.
This could multiply with a bunch of other things.
Yeah, no, I'll get to how you can get things in a second. Yeah. So we haven't completely done it yet. So if you put in an unrealistic calibration, which is 3 years life expectancy, which I mean obviously is complete rubbish, but you can see that you get pretty big TFP effects. So why do I think this is interesting to look at this, because people don't live for 3 years, is that I think that instead of having ability shocks when people die, it's much better to think about these ability shocks as something that hit you during the lifetime. And then you can just think of the gamma as something like the expected time until you get a new ability shock. So this is exactly what I'm saying here. You in order to get something, you should rather look at much higher frequency shocks. So instead of having them hit only during their lifetime, you also want to hit them only at death. You also want to hit them with an ability shock during their lifetime. So the idea is, for example, that people have entrepreneurial ideas and they're only very short-lived, or they introduce a new product into a market. So in developing countries, that's like, I don't know, they come up with a better way of making firewood. So
that's exactly what Greenwich Greenwich model does, right? If you have high aggregate shocks, you have less criminal activity. So that's where you get your misallocation effect.
well, I don't look at aggregate shocks, so I want to look at
Well, it's kind of like getting into kind of like aggregate shocks.
no, I'm getting into individual shocks, but at higher frequency, like idiosyncratic shocks. So all can be idiosyncratic shocks, no aggregate shocks. But no, I agree. You can probably get something out of aggregate shocks.
Like a paradigm shift.
Yeah. But yeah, I mean, if you shift the lambda around, for example.
Different people in different ways.
But so at the moment, we just want to think about people having different ideas and those kind of things, and those ideas switching very quickly over time. So also what we want to look at is the dynamics of the distribution. So I don't know if you know this website gapminder.org, which I think is pretty cool. So I actually took an example out of there, which is the kind of graphs we want to have is something like this. So they're like moving over time, right? So this was like the income distributions for 3 countries, like what is it? China, India, and the U.S. So in like 1970, like the U.S. is a lot richer than all of them, but these guys have more people, and you can simulate this over time. So this is the actual data, and like what happens over time is that they like kind of converge, right? So and we actually think that we can, like I'm pretty close to that, like have a model that does exactly that, while also creating like big capital misallocation. So
Wait, so if what you're saying is true, and it happens in the US also, then you should see a lot of CEO turnovers. I don't know what.
if you have high frequency ability shocks,
Yeah.
well, you do see that, right?
Yeah, no, that's what I'm saying.
Right. So that's exactly. So I think it's pretty realistic thing to think about is that you have high frequency ability shocks. If you don't take the idea of ability too seriously, but like think about ability as tied to like product or those
Why
kind of
couldn't I
things.
just hire smart managers?
Sorry.
Why couldn't I just hire smart managers? So like,
Right. So, in here, you think that you assume that people like have to operate their own production technology, presumably because they have some sort of special knowledge about that only they have. So it takes some time to train the guys, something like that. But yeah, why couldn't someone else just buy the firm? Those kind of issues. Yeah, we don't say anything about them. So I just want to very quickly. So what you usually look at, what we want to look at now is like there's actually a nice apparatus, like mathematical apparatus in like physics and chemistry and also mathematical biology for like modeling these distributions. So in chemistry, you look at the distribution of particles, for example, like in a fluid or something. And mathematical biology, you model like the age distribution of, I don't know, like some rat population. So those kind of exact same tools you can apply here. So in particular, you can let ability be a diffusion, it's called. So this is a sample path for typical diffusion. It's called an Ornstein-Uhlenbeck process. So it just like kind of wiggles around very fast, and then you can, from that, kind of back out what the aggregate distribution of ability involves. So I don't want to like bore you with the mathematical details of this and come to my conclusion very quickly.